So I'm a mathematician. That's a statement that tends to stop a conversation at a party or indeed at a conference at 9:30 in the morning. And I'm a mathematician who has the sad job of following Mark O'Malley as a speaker, so bear with me. As Jerry said, I'm a professor in the University of Limerick, and we have a group there called MAXI, the Mathematics Applications Consortium for Science and Industry, which is a mouthful. What we do is we do proof theorems, but we don't prove theorems for the fun of it. We prove theorems because they're useful. And in that sense, the mathematics that we do is, I think you'll find, distinct from the mathematics that's done most elsewhere in the country and indeed in many other places in Europe. The overall modeling strand is about using tools and techniques like that. So about using mathematical modeling techniques and tools. We have a special focus on stochastic processes, on stability of engineering systems, and on optimization. Again, because the problems are there not because they're nice mathematical puzzles that we like to solve, or at least not just because of that, but because they're useful to our colleagues in the Cs cluster on the engineering side or on the economic side. Stochastic processes, as you'll see, I'll be introducing my colleague Mel Devine in a few minutes to talk to you about some of the work that we've done, and that work's been in collaboration with Bord Gáis Energy, so Joe Collins is here to tell us how that was implemented in the industrial partners context. So they're hopefully showing you how the mathematics can be used or has been used and hopefully can be used by more of you in the future. So as Mark said, this is a strand of a large cluster, and the people who are associated one way or another with this strand are listed here. As you can see, there are a lot of them. On the right hand side, I've highlighted Mel because Mel will speak after me. I'm just going to present a very quick overview for you of some of the work we've done, and then let Mel dig into a specific example, because we think that's maybe the best way to try and show you how it is that we can work with industry and collaborators. So some quick examples on the stochastic processes side. Stochastic processes are the mathematical description of randomness, typically randomness in time. So if things are changing unpredictably or semi-unpredictably, the way that we would describe those mathematically are through stochastic processes of one type or another. So in particular, modeling markets is a big stochastic process area. Real options, informing investment decisions, how do you decide when to close one plant, open another plant, or pricing financial options and refit renewable tariff calculations. So Mel, really, these are Mel's pictures at the bottom. He'll tell you a little bit more about how that has been applied with some optimization work as well with Bord Gáis Energy in just a few minutes. Another more fundamental area that we've been working on with my PhD student, Kevin O'Sullivan, is on branching processes. So here we're looking at many different applications of this particular kind of stochastic process, including product uptake, so the modeling of innovation spreading through a network of people. How is it that people decide to invest in a new product or uptake a new product? And what kinds of statistical signatures of that can you see in real world data? My last slide, I'll just point this out to you. So in MAXI in Limerick, we've been running these workshops for about 5 years now. So I was speaking with Adele from Airgrid there at Coffee, and I've been asking Adele to come up with problems for this study group, and she said, yeah, but it's very hard to describe what it is that you guys do, which it is. So the European study groups with industry are week-long brainstorming sessions. We bring in mathematicians, applied mathematicians from all over Europe for a week to Limerick. 6 industry people present problems on the Monday. We spend the week, we break into groups, we spend the week working on those problems. We present a report at the end of the week and a written report within a month from the end of the workshop. So we've had a lot of successful collaborations starting that way or indeed growing that way. And one of them was with Bord Gáis Energy. So 3 years ago, Bord Gáis Energy brought their first problem to the European Study Group with Industry. It was hosted in Limerick. And in fact, they brought a second problem the year after that. And from that, we built a collaboration which resulted in Mel Devine's PhD studentship, which he completed last year. Mel is now a postdoc within the Cs cluster, and he's continued that work. So we thought the best way to explain to you, and especially those of you in industry who are trying to understand how mathematics might be useful to you, is to show you a specific example of how we did that. So I'm going to hand over to Mel. He'll tell you a little bit about his work, and then Joe will tell you about how that was implemented in Bord Gáis Energy in Cork. Okay? So I might pause, just if you have any questions, we might take them all at the end, so the three of us will stay here and we'll take those questions from you then, if that's okay. All right. So I'll pass you over to Mel. who is, as I said, a postdoc within the CEAS cluster. The modelling postdocs work closely with our collaborators in both the engineering and the ESRI. You'll see some of their posters outside as well, but this is about a natural gas market model.
My name is Mel Devine. James said I started in Maxi, I think about 4 years ago. I was doing a PhD project, and the project is kind of to work with Bord Gáis. So the title there is Modelling the UK natural gas market. It's in the postdoc now, and in January this year I spent an 8-week kind of consultancy project actually implementing the results of the PhD so that Bord Gáis could actually use it kind of from day to day. So just to give you a bit of the project background, demand for gas in Ireland and the UK is becoming increasingly uncertain. I suppose the main driver of uncertainty in gas demand is typically weather, or mainly temperature. So when the weather is cold, people tend to demand more gas, and when obviously it's warm, then there isn't as much demand for gas. But over the last couple of years, another source of uncertainty is come on board, and that's the increased levels of intermittent wind power used to generate electricity. So when wind is blowing, there isn't as much need for gas powered generation, but then when wind isn't blowing, there is a need, or greater need for it. So that brings uncertainty to gas demand. So one of the main questions I get asked, I suppose, about this project, okay, so we're Irish obviously, but why the UK market? So in Ireland we import approximately 90% of our gas from the UK, and this gas only makes up about 5% of the total UK gas demand. So essentially what that's telling us is that the Irish market is heavily dependent on the UK gas market, and I suppose it's a small part of the overall UK gas market. I suppose from a company like Bord Gáis's point of view, the wholesale gas prices are set by the UK gas prices. So that's why there's, I suppose, a need to maybe model the UK market as opposed to maybe the Irish market. Natural gas is the largest source of energy used to generate electricity in Ireland. Then the aim of this project was to model the flows of gas whilst incorporating the uncertain nature of demand, or to give it, I suppose, the technical name, stochastic nature of demand. So what the model does, it attempts to replicate the daily decisions that are made on how to meet gas demand under this uncertain information about future gas demand. So I suppose what we attempted to do was to replicate the daily decisions of what happens in the UK gas market. So I suppose on any given day, the market has to meet demand, and it tries to do that at least cost. But when they're making those decisions, they must take into account all possible future demands as well, and the uncertainty around future demand. So once those decisions are made, say for today, once today's demand is met, we move forward to tomorrow, where the exact same decisions are made again. We have to meet that day's demand. Once again, we're expecting all possible future demands. Once tomorrow's demand is met, we move forward to the next day, same decisions, and so on and so on. So I suppose in terms of the model, what it does, the exactly known demand on day 0 or today must be met at a minimum cost, while ensuring all possible future demands also met at a minimum expected cost. And once that is done, the model moves forward to the next day or a new optimization and makes the exact same decisions. Just to kind of talk, just one kind of technical slide on kind of the background of the model without kind of going into too much detail. So I suppose what we have here is minimizing kind of cost of production plus the cost of injections to storage plus withdrawals from storage plus all expected future costs, future production, injection, and withdrawal costs. And the two main constraints then is that we must meet today's demand, but we must also respect all possible future demands. So, and then we have some other constraints that I didn't put up, so production, storage, and importation constraints. So this kind of maybe didn't bring you some of the results in the model. In actual fact, this is an actual demand profile from the UK gas market from April 2010. So basically what this graph tells us here is how the different sources of supply in the UK met demand for that year. So it's because we can see the seasonal pattern to gas demand. So as kind of maybe one might expect, gas demand is quite low in the summer and then high in the winter, basically reflecting kind of temperature patterns. So there's 5 sources of supply there. In blue is the largest one, is the UKCS. And the UKCS stands for United Kingdom Continental Shelf, which is the indigenous gas supply in the UK. The second one then is Norway, so these are imports coming from Norway into, I think mainly Scotland, through pipelines. And then the next one is liquefied natural gas, which Minister O'Dowd touched on that there at the start. So liquefied natural gas is gas that's frozen and it then can be transported in ships around the world. So in that the green there, it's not coming from any specific place, but I suppose places like Qatar, Trinidad, Tobago. Then the next one then in black is Europe, or continental Europe to be precise. And these are two pipelines, one coming from Belgium and the other coming from Holland. And then the final one there is supplies from storage, and that's coming in mainly in kind of the high demand winter time in purple there. So I suppose the aim of the work was maybe to try and replicate this data. So this is what the model came out with. No, it's not exact, but we can see that I suppose that we still have the UKCS there in blue is the largest source. The next two, probably LNG is next, but it's probably on the same scale as Norway. And then the next source is Europe, and we can see that storage supplies are coming in generally in the high demand winter time. So as mentioned there, storage plays a big part in meeting kind of peak demand. So there's two types of storage, or two main types of storage that you would generally see in the UK. The first one is long range storage. What this graph shows here is just for the same year from April 2010 to April 2011, basically showing us in red here what actually happened, and in the dashed blue what was simulated by the model. So with long range storage, you can see it's a very seasonal pattern. We have injections in summer and then withdrawals in winter. I suppose as the graph shows, the model does a quite reasonable job of capturing that seasonal variation in the amount of gas and long range storage. The second type of storage facility you'd see in the UK is medium range storage. So again, the red line here is just the actual, what happened for that year, and the blue is simulated by this model. So again, like long range storage, it has a seasonal pattern of injecting in the summer months and withdrawing in the winter months. But I suppose in contrast to long range storage, you also have a kind of a weekly and seasonal variation. So maybe like you're going up and down here, which we didn't see in the previous graph. So I suppose in the last graph, the model did quite a good job of replicating the actual. In terms of medium range storage, it didn't do as good a job. It did capture some of the seasonal and monthly effects. I suppose some of the places that didn't do as good was maybe in this place here, where in the actual, the withdrawals occurred kind of throughout the winter period, whereas in the simulated, it occurred mainly kind of in the really high demand kind of around Christmas time. So I suppose that told us either one or two things. One, that the model underestimated the cost of withdrawing from medium range storage, or perhaps that those in the UK might be better off kind of emptying their medium range storage kind of in the really high demand Christmas time. So I suppose the next question that leads up, so why is this useful to Bord Gáis Energy? So why would a company kind of invest time and energy in kind of getting these type of results? So I suppose the main reason is for pricing and kind of making predictions about the future. So this is the next graph. I'm just going to show you kind of a forward curve starting from May basically this month here. So in the blue line here we have the actual forward curve. No, sorry, in black we have the actual forward curve from May 13 to next year. So basically a forward curve, it tells you the price of buying gas for each day in a particular month. So because we have 12 values there from May 13 to I suppose March 14. So essentially we have the actual forward curve, and then we have the blue one predicted by the model, and then we have upper and lower ranges for that. So I suppose in terms of the black and the blue they're quite matching. So the model is in line in essentially of what is happening in the current forward curve. But I suppose the extra information that the model has given us is these upper and lower bounds. And I suppose the second thing it's telling us is, I think in August here, so there's a spike here in the predicted. And the reason for that is that we fed into the model scheduled maintenances that are due in the UKCS and in Norway. So essentially, what the model is telling us that we should see maybe a bit of a spike in August because of these maintenances, that perhaps the actual curve isn't getting it at the moment. So just kind of to summarise, so we developed a model of the UK natural gas market that incorporated the uncertain nature of demand. The flows of gas obtained from the model replicate actual historic flows. And why is this useful? The model can be then used to test various stress tests. So, as an example, how would that price curve be affected if there's an extremely cold winter, or if there's a sudden loss in, say, LNG supply or Norwegian supply? And then just to finish up, I suppose, as I was saying to start, Bord Gáis actually use this model now as a risk analysis tool.